If you need one, I'll get one for you. Raise your hand.
So with this is slope-intercept form. You're going to be seeing a lot of this. We've already seen a little bit of it, but we're going to go ahead and talk about what each letter means. So the first thing we're going to talk about is y. And another way we can talk about y is output. Output. Remember how we had input-output problems a couple days ago? So another way we could talk about it is f of x equals. F of x equals. That's another type of output. Other words you'll see to describe output is total and range. This is our range variable. So we'll talk a little bit more about domain and range. So the range is like on the y-axis, how far your graph goes. Is it from like negative infinity to infinity, or what is it from? Okay, so that's your range. And this is our dependent variable. Dependent variable. Meaning that whatever answer is here is dependent on this side, whatever we plug on this. So this is independent. It's going to be changed by the function. That's why it's by itself, that f of x. It's all by itself over here. We all got this? So we have output, f of x equals total, range, and dependent. Okay? So then the next one we have is m. Can anybody tell me what m represents? Slope. Awesome. M is our slope. So whenever I think of slope, I think of like ski slopes or a hill, and it's going to be how steep something is. It's going to be that slant slope. Okay, so this can be represented by the formula y2 minus y1 divided by x2 minus x1. That's one of the formulas you'll see for it, which this is the same thing as rise over run. Yeah. Okay. So a way you might see this in your word problem sometimes is this is your rate of change. Your rate of change. So how fast is it changing? How steep is that slope? So this is also the value being added. Right? Value being added. Okay. And then the last thing we'll see representing this is between here, I'm going to write a couple words, and it's per, each, and every. Per, like miles per hour. Each, I eat 5 cookies each day. And every. For every cookie, I have a cup of coffee. So I have a problem. So whenever you see these words in a word problem, it's going to be dividing. The first number is going to be your slope, like 5 cookies. That's my slope per day. So that's leading me into x. So for x, this is going to be, if this was our output, what is this? Input. So we have our input. So this was our dependent variable. This is our independent variable. Independent. Meaning whatever we plug in here, it stands by itself. We plug it in here, and it's going to affect that. This is dependent upon this. You are your parents' dependents. Like, you need them to pay the bills for you right now, right? Yeah. Okay. So then over here we have range, and I mentioned it. This one's going to be domain. So this is our domain. This is our x. And so like I said, this is usually going to be, when you see these per, each, every, this is usually going to be a unit of time. So like 5 cookies per day, 60 miles per hour. So this is going to be usually a unit of time when you're seeing it in a word problem. Does that make sense? Awesome. Okay, so our last one is plus b. Can anybody tell me what that b stands for? Y-intercept, yes. So we have our y-intercept. So the way I remember this is I think of, like, when I hear the word intercept, I think of an intersection in football when the other team cuts in and they intercept the ball. They stop it in its path. It's another thing intersecting it, right? So this is where your line crosses the y-axis. It's going to intersect. There's going to be an intersection on the y-axis. Okay, so words that we usually see here, the first one I think of is beginning, because it starts with a B just like this. So beginning. Sorry. So beginning, that's going to be a word that lets you know. So beginning at 5 p.m. or beginning at 7 cookies or beginning at this value. That means that at time 0, right, because we're just starting, we're going to have this value. So beginning, another word synonymous with beginning is starting. So your starting value. So normally when I start my car, I'm going 0 miles per hour because I haven't moved yet. Okay, another one, synonym, initial. This would be your initial value. The first thing you see, initials. Your initials are the first letters of your first, middle, and last name, right? Initial. And this is where, like I said, it crosses y-axis. Does that make sense? So these are going to be most helpful. You want to keep this with you because it's going to be most helpful when you're going over word problems. And so Ms. K is going to walk you through a word problem now for that. Does anyone need more time writing this down? Okay, 1 more minute. Okay.
And so the next thing we're going to be working on is the one right underneath where it says Daniel moved. And we're going to be kind of breaking it apart using this equation. And you're always given y equals mx plus b on your formula sheet, which is what we're going to do. We'll give out next time. And so we want to make sure we understand what is m, b, x, and y. And this is kind of the basis of like your whole unit. Okay. If you still need this up during independent work, I'll let you guys copy this. So I'm a little short, so I'm going to move this down. There we go. All right, so you guys have the top part. You don't need to write this out. You might just want to write the equation at the top. Like I wrote the equation right under the word problem, but we're going to be breaking it down right now. And so it says Daniel moved into an apartment complex. So this is like an example of that rent example. He had to pay $500 initially for a security deposit. So does he pay that every month or does he pay that one time? One time, right before you move in. Just like when I said Bailey and Larry ate my carpet, they're not gonna have me pay that after. They're gonna have me pay that before, just to make sure that that is covered. And I talked about yesterday, my dogs ate my entire carpet. I just moved and I got none of my security deposit back because that was what that was for. And he then has to pay $1,200 per month on rent. Write a linear equation to represent this situation. So first, $500 initially. What would that be considered? Your B, or your beginning amount, right? So we know that $500, and you can write this out if you want. You can just write the equation out, but we want to break it down because $500 initially is what I'm starting with. So no matter what, I need to pay that money before I move into my apartment complex for his security deposit. Then he has to pay $1,200 per month. Now, is he paying that one time or adding every time it's another month? He pays that. He's adding that over and over again, right? So that would be my slope. The $1,200, and I know it's my slope also because it has per, each, every. I know it's being added each time. So per what? Per month. And so your month is what we consider your X month. Right. Now, the last one is your Y. What are you paying? Are you paying coins? Are you paying those invisible dollars that my husband is spending on 2K? What are you spending?
That's fine. That's fine.
I swear.
He spent $200.
Not $200, those coins or whatever they are. But what are we getting out of here? Money, right? Dollars. So first we break it down like that. And so now when I'm writing my equation, I know it's Y equals 1,200X and plus 500. Remember, it's 1,200 because it's adding each time. What if something was subtracting or decreasing each time? What sign would be in front of that 1,200? The subtraction or a negative, right? So when we're adding, it's going to be positive. When we're subtracting, it's going to be negative. So here's the equation. That's my answer to the first part. And so you don't have to go through this each time. Sometimes you can pick out, okay, that's my slope, that's my y-intercept. I'm going to write the equation. But when we get to these word problems, this can help you out. So I want you guys to write this. I wrote this on both sides of mine because I could really fit it. So if you look right here, here's my first question. Here's my second question. Write it down in your notebook, these two questions, and we're just going to learn how to answer them. That's the whole lesson for today. So you're going to write these down somewhere. Even I wrote it on either side of that little paper. If you want to write it on the next page, wherever you have room, I would write it like right here, like on either side of the question. What? They're like diminishing. I need to buy some more. Is there enough?
No.
Doesn't work. It's not awesome.
Yeah, I don't want to get a second.
Yeah. I spent like so much money on this.
Oh, I did yesterday.
Okay, so it says how much has he paid the complex in 3 months? So we have this equation, right? Where is months? Up here. X. Do you guys see that? I labeled it X. So I'm going to rewrite the equation, but instead of X, what do you think we should put? 3. Because we want to find out how much is he paying total in 3 months. So I'm going to put a 3 right there. Then I'm going to solve. What is 1,200 times 3? 3,600 plus 500. 4,100. Perfect. So how much has he paid? We want to know how much he paid. So we're trying to find the Y. And we find out that he's paid 4,100 to this apartment complex in 3 months. Does this make sense how we kind of labeled it and it made it easier to where we plug things in? Okay. The next one is how many months. So we know we're trying to find our months. So we know we're trying to find X. Would it take for Daniel to have paid 19,700? So how many months would it take for him to pay that much money? So what am I plugging 19,700 in for? Why? Because that's my money, right? And so do you guys kind of see why evaluating functions and those equations, why we kind of started off and harped on that? Because it has to do with like the rest of your unit or the rest of your year, basically. So how do we get X by itself here? Good. Subtract our constant for 500. And you end up getting 19,200 equals 1,200X. Then how do you get X by itself? Divide 1,200 on each side. because that's what's attached to x. And you end up getting, and I'll zoom, or I'll scroll up, you end up getting x equals what? What is it? 16? It's on my book. What does it end up being? 16. So it ends up being x equals 16. That means in 16 months, he's paid $19,000 for this apartment. And so we solved it just like a two-step equation. So we moved the constant over, we're trying to get x by itself because we're trying to find how many months. Does that make sense? So we don't need to make this chart every time, but when they're asking you to plug values in, it's probably helpful to at least label what you're trying to plug in. So what we're going to do now is, do you guys see this worksheet? So we're going to make sure everything's glued in. And we have made a practice worksheet for you guys to practice. Some of them are just writing in the equations. Some of them are plugging them in. And so we're going to walk around and stamp if you got it correct, because we want to make sure you got this down. Then last 15 minutes of class, or last 10 minutes, we'll give you that check for understanding. Every 4 answers on this page you get right, you get a brain buck. So remember, 2 brain bucks is a snack size candy. You can cash that in at any time. So every 4 stamps you get on this worksheet, you get a brain buck. 2 brain bucks gets you snack size candy. Yeah, every 4 questions that you get stamps on, you get a brain buck. Yeah. You don't have that paper? Okay. And then here's, you can take all these. Okay. And then you can use, I have the answer key.